what we're going to look at now is how to calculate utilities, so expected utilities in a game. Oops. Calculating utilities of strategies. So the idea here is that if I define my game as before, so I'm going to first of all start by importing Nash, and then I'm going to create the Battle of the Sexes game. Actually, no, I'll do the Matching Pennies game. So we do that by creating a two-dimensional matrix. So 1, -1, and 1 and -1, 1. But whilst in the previous video I showed how we could do that by passing a list, in fact we can also do it using a NumPy array. This makes no difference. In fact, Nash underneath converts everything to NumPy arrays because it's doing some linear algebra. But we can also do that. So now if I create matching pennies by going nash.game of A, and let's take a look at that, we see that we indeed get that zero-sum game. Now, strategies in game theory are essentially vectors of probability distributions. So for example, sigma r is how I'm going to denote the strategy of a role player. And I'm going to use a NumPy array for this and say that 20% of the time the role player plays the first strategy, and so 80% of the time they play the the second one. And here's the column player's strategy, 0.6 and 0.4. So 60% of the time they play their first column, and 40% of the time they play the second one. And once we've done that, we can calculate for this particular game what is the expected utility to both players. And we can just do that by going the game and then querying it as if it was a dictionary. So sigma r and sigma c. And if we look at that, we see that in this particular case, the row player gets a utility of -0.12, and the column player a utility of 0.12. And we can change that. So let's see what happens if it was actually, so the column player is playing the first column more often. So we're here more often, and the reason the row player is getting a negative utility is because they're more often in the second row. So let's just swap that around, put 0.8 and 0.2, and we see that the utilities flip around a bit. And if we even just change it to 1 and 0, so the row player is always playing the first row, then we see that utility goes up even more. So that's how we can calculate utilities of strategies using Nashpy.